All right, so this video is actually a sort of intermediate video. It's like the peanut butter and jelly of your peanut butter and jelly sandwich. It's mostly review, okay? It's very important that you remember these properties of exponents, all right? So if you're good with properties of exponents, feel free to skip it and start working on the homework, all right? But if you want a refresher, here it is. And again, at any point, you can pause the video and write these properties down if you'd like to have them yourself. Otherwise, we are going to just get going. Example 2, simplify and write as e to the kx. All right. So we'll talk a little bit about what that means, but essentially it's going to mean simplify it and write it in this nice form to prepare us for the next section. All right. So let's go over here. Part A, e cubed is getting raised to the exponent of x divided by 5. So we're going to use that second property, right? We have an exponential raised to another exponent, so we multiply those exponents together. All right, so this is going to be e to the 3 times x over 5. And remember, we can do a little of moving around here, right? This is 3 over 1 times 1 over 5 times x. This is another way of kind of writing this. And this is a nice way of writing it because then it'll get us that kx formula, which makes it a lot easier to differentiate when we do that in the next section. It becomes e to the 3/5 x. All right, so 3/5 is our k value here. And eventually we're going to really like it in this form. It'll make the derivative a lot easier when we have to use the chain rule. All right, but that's not this section. So I'll just slow down. I'm getting a little excited. Let's do another one. 1 over e squared to the x. So, you know, upon first glance, this is the same as part A. Oh yeah, just put the x inside. Let's rewrite the inside first though, because I notice it's wanting you to write it as e to the kx, not 1 over anything, right? There shouldn't be any 1 over anything at all. So let's deal with that using properties of negative exponents, right? 1 over an exponential function is the same as no 1 at all with a negative exponent. So we need to use negative exponents here, okay? So this is going to be e to the negative 2nd power raised to the x. That negative exponent right here is what flipped it to the bottom and vice versa. And now we use that property from before. Okay, exponential raised to an exponent. Multiply those exponents together and we're going to e to the negative 2x. Is that nice form that we were asked for right here. Again, if you really want to be clear here, k here is 3/5 and k here is negative 2. You don't have to write this, but it's good to kind of see where it is. All right. All right, let's do another one. Part C. We'll do it on the next page. Why not? Part C is going to be the square root of e to the negative x times e to the 7x. And again, there's a lot going on in this one and a lot of ways that you can start. And you're not really going to know the best way to start until you've done more of these, all right? But even if you choose a bad way, you'll still get to the right place eventually. It may just look a little messier. So what I'm going to do is say, okay, I want to combine these exponents, exponentials. All right, this is going to be the square root of, which property is this? The first property, right? We have 2 exponentials with the same base, and we want to add those exponents together. All right, so this will be e to the negative x plus 7x. Oh, negative x plus 7x, that's 6x. Look at e to the 6x as on the inside. And you might say, Jason, where'd your square root go? You can't just get rid of a square root, Jason. That's cheating. Well, you'd be right. Here it is. Remember, square root is the exponent of 1/2, which is how we took the derivative of square roots. Write it as an exponent of 1/2, use the power rule. The exponent of 1/2 is going to be really nice here because now we multiply those exponents, right? This is e to the 6x times 1/2, which is just e to the 3x. And that's our answer here. And again, k in this case is 3. These k values all have a very special meaning that we're going to talk about in the next section, but we won't talk about them yet. Last example for the day. Oh no, last example of example 2, and then we'll do 1. for the other one, or 2. Yeah, all the examples in this video, why not? E to the negative 3x divided by e to the negative 4x. Again, there's a couple ways of starting this one. You can subtract the exponents because they're getting divided, or, right, negative exponent means you flip it. So we can move the top to the bottom, and we can move the bottom to the top, right? So that e to the negative 3x on the top is an e to the positive 3x on the bottom. This e to the negative 4x on the bottom is an e to the positive 4x on the top. That's one way of approaching this. And now we subtract their exponents. 4x minus 3x is 1x. In this case, our k value is just 1. All right. So we're going to do one more example here, just to give a little refresher on exponentials. Solve for x. Again, a lot of the material in this chapter, a lot of the material in this week is going to rely heavily on college algebra. So if you don't remember your college algebra, it's going to be a little harder for you. If you do remember your college algebra, this chapter shouldn't be too bad. See how it goes. E to the 1 minus x equals e squared. If we have two exponential functions equal to each other, they're one-to-one functions. So that means their insides have to be the same. Right? This blue thing and this blue thing have to be the same. We just say, okay, when are they the same? Oh, this equation is a heck of a lot easier to solve than where I started. Right? Let's subtract 1 from both sides. We'll get negative x is equal to positive 1. Divide both sides by a negative 1, and we'll get x is negative 1. And we check our answer, right? If we wanted to, we check our answer and say, okay, is e to the 1 minus negative 1 equal to e squared? And yeah, it is. 1 minus negative 1 is positive 2. E squared is e squared. Yeah, that's true. All right, last example of the video. Part B. We're going to do this on the next page. I just want to make sure it fits. All right, 4 e to the x times x squared plus 1 equals 0. Now this one looks real kind of bananas. But remember, the principle of zero product says that if you have two things that are multiplied that equal 0, this is going to be true when each piece equals 0. All right, and we solve each of these individually. Divide by 4, e to the x equals 0. The range of e to the x is positive. E to the x can never equal 0. This is impossible. Right here. You could try to take the natural log of both sides, but you get the natural log of 0, which doesn't exist. Over on the right-hand side, we get x squared equals negative 1. So x is going to equal plus or minus the square root of negative 1. That's possible, but that's not real. We will not be dealing with complex numbers in this class. It's plus or minus I. So what are the answers? What are the solutions here? Well, we have a couple solutions. One of our solutions is it's not possible, and the other solution is it's not real. So we'll just conclude and say no real solutions here. Which means that if we were to graph this function up here, if we were to graph the function right here, it would never equal 0. The function value will never touch the x-axis. And indeed, it does not. All right. Good luck. Have fun.